we're going to be looking at the 3 different ways that we did, like for example, on your posters, that we did a table, we did a equation, and we did a graph. So if we're going to look at where do we find that slope on each of those, just as kind of a, and again, some of this is review from last year. So if we are looking at a graph and we are looking for unit rate, again, unit rate is the y coordinate. When x equals 1. So unit rate is the y coordinate when x equals 1. So, for example here, if we had a coordinate plane and we had a line, a proportional relationship, so we had a line that was going through 0, 0. Whatever the y is, where x is 1, that's going to be like my slope or my unit rate. So if this was telling me how many miles I went in so many hours, I might have points way out here that are telling me, but the one that's right here at 1, that's telling me for 1 hour, how far am I going? Now we also might have graphs that we need to change to unit rate. So for example, I might have a graph where I don't know what 1 is, but I do know that when I got to 5 hours, I had some measurement there that I could see, a point that was on that graph. And I might not know for sure what 1 or 2 or 3 or 4 is, but I do know what 5 is. And in that case, we want to make sure that we are changing it to a unit rate. So if I have y over 5, and I want to have a 1 in my denominator, because remember, unit rate is a rate that has a 1 in the denominator. What am I going to have to do to 5 to get 1? Divide by 5. So I do the same thing to my numerator, y divided by 5, so that I would know for 1, what is my unit rate. So what we're going to have in this unit or this section is we're going to have, like, we might have a graph and we're comparing it to a table, or a graph and we're comparing it to an equation. So we need to know where is that unit rate so we can compare it in each one. Let's write this next one down really quick, which is an equation. If we have an equation and we're looking for that unit rate, we are looking for that constant of proportionality that we talked about last year. And again, remember, we're talking about proportional relationships here. So an equation, that constant of proportionality. And again, remember, that's also a form of slope. So we're kind of introducing that word that when we're talking about constant proportionality. Slope is the same thing for that. However, you know how, you ever remember like in grade school where you learned about squares and rectangles and you're like, oh, rectangles are squares, but not all squares are rectangles, kind of stuff. This is kind of the same thing. Constant proportionality is slope, but slope is not necessarily always the constant of proportionality. So we use them interchangeably, but it only means when it's a proportional relationship. So on that, remember, we had y equals kx. And remember that kx, that is my constant of proportionality. We also might see that as that is a slope. Like I said, constant proportionality is a slope. And it is also a rate. So that one little number there is so important in our equation because it can represents all those things, which are basically all the same thing, but we've got lots of different words we use to talk about those. All right. So we'll finish. Okay, so we are going to look here at some examples of this, because what we're doing today is we're comparing. If I've been given this in two different ways, if I've been given information in a table and a graph, or a graph and an equation, how do I know which one is a greater rate of change? Look at here is on the first one. We've got a graph of Diego running, and then we've got an equation that talks about how Kevin was running. What? So we need to look and see which one of these ran at a faster pace. So in order to do that, we need to know the unit rate of each. So on a table, if I want to know the unit rate, I should be looking at what's happening when x equals 1. So when x equals 1, what is my y? 20. So Diego is running 20 miles in 1 hour. That is Diego's rate. Kevin then, they're giving me an equation for Kevin, y equals 10x. So it's an equation, remember, my unit rate, my slope, my constant proportionality is what that k is. So what, in this equation, what represents his unit rate, Tyler? 10. So remember again, that's y over x. And y is my distance, so distance was in miles, so we can see that it's given to me in the same way. 10 miles in 1 hour. So the question was, who ran at a faster pace, Kevin or Diego? Diego. That's because people were yelling, "Go Diego, go!" So he ran faster. No, go Diego, go. No. All right. So go ahead. I'm going to have you guys move in with your groups here and look at number 2. Find the unit rate of each of those and answer that question. Okay, so taking a look at this, when we look at apartment A, and again, we're looking for the constant proportionality or the unit rate. For 1 day, how much did apartment A use? 30 liters. And then apartment B, what was their amount that they used per day? Belle? 15. 15 liters in 1 day. And so the question is, which apartment consumed less water? So which one was less, Olivia? Apartment B, because they consumed less water. All right, flipping that over really quick. Go ahead and do number 3 with your group. Go ahead and do number 3 with your group.